With our physics exam fast approaching, we're stressed, studying late and not sleeping nearly enough, drinking too much coffee, endlessly flipping through our physics textbook to retain as much information as possible. Going to bed at 4:30 before our exam day is scary. If we're lucky, we'll wake up on time. But knowing us, we'll miss our alarms and end up sleeping in. If we need to get to our exam room in a pinch, we'll just rent a bike. We may not be the best bike riders in the world, but knowing our velocity and acceleration, we can definitely figure out if we can get there in time. Right away.
In this video, we will be analyzing the motion of Neetu's bike ride to create a position time graph using the Logger Pro software. Using Logger Pro, we were able to mark the motion of the rider and analyze the position of the rider over time. From this generated graph, we will be demonstrating how to create a velocity time graph. The first step is to mark the origin of motion, which we place in the center of the front tire. Next, a scale was given to the video, a measurement shown in the green line of 7.15 meters. Next, data points were placed at the beginning of the front tire every 10 frames of the video, which was recorded at 30 frames per second. This software enabled us to create our position time graph. The graph on the right shows both x and y distance, but for the purposes of this demonstration, we will be concerned with only the x position. The graph is shown here. Here is the analyzed video showing the recorded data points. Here is the final position time graph. We have the data points made by the Logger Pro software. From the previously generated PT graph, we are able to plot a velocity time graph. Velocity can be calculated from position time graph using the slope of the position time graph. In fact, we can plot a velocity time graph by finding the slope of the position time graph at point intervals. Velocity is equal to the change in x over the change in y, which translates to the change in position over the change in time. For this example calculation, we will be going from point 2 to point 4. Therefore, the velocity is equal to 0.7308 meters minus 1.619 meters over 0.300 seconds minus 0.9760 seconds. This gave us a velocity of 1.3316 meters per second. The other velocities will be calculated in 2-point intervals using the generated data points. The first point will be omitted due to negative time. Once the velocities have been found, we can generate our velocity time graph, shown here. We can tell that because of an overall decreasing velocity, although very small, the acceleration is not constant. Let's calculate average acceleration. Average acceleration is the change in velocity over the change in time. We will use the final and initial velocity and time data points shown in the graph. We found an acceleration of negative 0.0359 meters per second squared. Although this is a deceleration, it is very minimal. This calculation of acceleration includes the anomaly of a spike in velocity shown above. We can see here that this spike in velocity could have been caused by external factors and maybe riding over a ridge. Shown in the graph on the right, the acceleration was found by the software to be negative 0.034 meters per second squared, which was very similar to the value we calculated.
Lucky for us, we made it to our exam on time. Yay!